Good morning. Our group will be presenting to you our IIoT group project. Our project will be focusing on an energized smart home. In today's world, buildings account for nearly one-third of the final global energy consumptions. Electricity demands for buildings have grown rapidly over the last 25 years, which amounts to nearly 60% of the global electricity consumption. As technology advances, the usage of smart technology is becoming a growing trend in the community. By leveraging IoT devices and sensor networks, it enables real-time data monitoring, particularly in energy management for smart city applications. Therefore, the problem statement we are tackling is to reduce energy consumption by improving energy efficiency and monitoring noise pollution in the surroundings. Now, moving on to the different issues that the our group is tackling. To improve energy efficiency, light sensor is used to detect light intensity of room and on or off light bulb automatically. We will also be able to change from auto to manual mode. The temperature sensor is able to detect temperature and changes the speed of the fan. For noise pollution, the sound sensor will detect the residential noise and usage of gas for feedback to send to the government so that new measures can be implemented. For monitoring and keeping track of data, gas is used. The LCD display screen is used for displaying the status. For remote access and control, MQTT app will be used. These are the different components that we will be utilizing for the project are the light sensor, LED bulb, temperature sensor, sound sensor, servo motor and LCD display. And it also shows how the components interact with one another. The component that I'm assigned with is the light sensor. The purpose of the light sensor is to measure the light intensity in the environment and send low or high signal to ThingSpeak to indicate if the room is bright or dark. This component is essential to the project as it uses the light sensor bulb as a sort of light-dependent resistor and send input of light intensity for LED to turn on or off. The MKR board would indicate red for dim lighting and green for high lighting. If toggled to manual mode, it will be in blue. The key innovation for this component is that it will be able to toggle to either manual or auto using the MQTT interface and allow the light bulb to function by itself to on or off manually. During daytime, it would receive high value from light sensor, whereas during nighttime it would receive low value. The component that I am working with is the LED bulb. The purpose of this LED bulb is to receive data from ThingSpeak and to turn the light bulb on or off according to the light intensity in the room. The component is essential as it is able to provide a light source to the room based on the environmental setting. This prevents unnecessary wastage of energy. The key innovation for the LED bulb is that we will be able to toggle it to either auto or manual mode from the MQTT interface. In manual mode, we will be able to switch on or off the LED bulb from MQTT. For the RGB indication, when there is no connection established, the RGB color will be red. When the auto mode is activated, the RGB color will be green. When manual mode is activated, the RGB color changes to blue. The component that I implemented in the smart home solution was the temperature sensor. The primary function of this sensor will be to sense the surrounding temperature and send the detected temperature to a cloud platform where other input devices would read and act according to the temperature. There are 3 different LED lights to indicate different surrounding temperature. First is the red LED light, which would light up when the temperature is lower, then 20 degrees indicating cold temperature. A green light would light up if the surrounding is between 20 and 30 degrees indicating medium temperature. And finally, a blue light would light up when the temperature goes beyond degrees indicating the surrounding is hot. The component that I am doing is the servo motor. The purpose of this servo motor is to simulate the alteration of the fan speed based on the surrounding temperature. When the temperature reaches less than 20 degrees Celsius, the motor will run in low speed and the LED board will show cyan. When the temperature reaches in between 20 and 30 degrees Celsius, the motor will run in medium speed and the LED board will show magenta. When the temperature reaches more than 30 degrees Celsius, the motor will run in high speed and LED the board will show yellow. The motor is the only component that can simulate the rotating speed of the fan. One of the key innovation is that the user can choose to switch on or off for the fan using the MQTT panel. The component I was in charge with is the sound sensor. The primary purpose of the component is to monitor the noise level in real time, providing the monitoring of noise levels across various noise hotspots. The noise level by the sensor will be classified by 3 colors: green, yellow, and red. Green represents low to no noises, yellow represents medium sound level, red represents high or loud noise. The noise level data will be sent to ThingsPeak, which will be sent to the LCD screen for the user to view and aware of the noise level. The noise level data will also send to Google Apps Script, which the data can be recorded, which the user can feedback and inform the local authorities to enforce the noise control measure around the area. The key innovation can enhance security and safety. For example, the sensor can send notification to user when the noise level exceeds certain level when the user is not at home for potential hazard issue. The component I am using is the LCD RGB display. Its main purpose is to act like a smart display, allowing you to monitor the various real-time data received from multiple sensor inputs. The component can display 3 different real-time data from 3 different inputs and updates constantly with the different colors representing the different modes. Through our MQTT application, we can toggle between the modes to display the various modes. This component is essential because it provides a visual feedback of the component's data, allowing users to have a better understanding of the current state of the system and surroundings and make informed decisions. Next, we will be sharing some of the challenges our group faced. The temperature formula was hard to implement for the temperature sensor as we were unsure about the formula that has to be used. Based on further research that we did, we were able to implement the right formulae to calculate the temperature. Sound sensor unable to directly convert to decibel values, hence it was hard to interpret the what was considered high-level noise. Also, there was a 15 seconds update interval, which delays the overall flow of the system. According to a report by the International Energy Agency, IoT-enabled smart home energy management systems could lead to energy savings of around 60 terawatt-hours per year by 2040. This slide summarizes the different components, their uses, and the platforms that we utilized for communication between the different components for our project. To summarize, by using the various sensors that our group has utilized, it can delineately lead to huge amounts of energy savings in the long run. For future developments, to improve the energy efficiency, the system can be modified to automatically deactivate the light sensor at sleep hours so that the light sensor doesn't have to be active while the person is asleep. For the motor, it can be modified in a way that it will be turned off automatically when there is no one inside the room. Lastly, in addition to the temperature sensor, an additional humidity sensor can be added to detect the humidity of the home to give extra feedback on the environmental conditions to the owner. Thank you.